learn a bit harder version of system of equation problems. You're going to do, you're going to manipulate by multiplying by 2 and all, a bit different than what you did before. So coming to example 6, you see two system of equations are given. The solution to the given system of equations are x comma phi y. What is the possible value of y? So we just have to find the solution for this system of equations given. So how can we find that? They're given two equations, y plus 3x equals 0, and then x square plus 2y square that equals 76. We can able to turn this equation as y equals to negative 3x. That's so easy to get. Instead of doing the elimination procedure, we do substitution, because y is single term, it doesn't have coefficient. That's what we learned in the beginning. When there is no coefficient, we use which is the fastest way. Now we just substitute x plus 2 into y. What is the value of y? Negative 3x. So negative 3x on substituting inside, that equals 76. So x square, that's going to be 2 3 plus 2 into not negative 9x. 9x square you're going to get, that equals 76. So x square plus 18x square, that equals to 76. And then that's going to be 19x square equals 76. X square equals 76 divided by 19. Yes, that x square equals 4. So x equals to plus or minus 2. We have the value of x, we have the value of y as well. What do we need actually? We need actually y value. So to get that y value, we substitute that x equals to plus or minus 2. We have y equals to minus 3x. We put x value equals to positive 2, and we put x equals to negative 2. Y equals to negative 3x. So we are going to get y equals to negative 3. When you keep positive 2 and when you keep negative 2, you are going to get y value as negative 6 and y value as positive 6. So the possible y value is negative 6 or positive 6. Coming to the next one. So here now it's about graphs. So you already know about graphs intersecting at one point which have one solution. Graphs intersecting at many points, it will be infinitely many solution. Not intersecting parallel lines, no solution. That's what we are going to discuss. Now you see here, when equations in the system are graphed, the intersection points are the solutions to that system. So when you take equation and graph it, and take the second equation and graph it, and the intersection points of that systems, you see the intersection point is 2, 3. That will be the solution of those system of equations. So if they have more, then it will be infinitely many. If they don't have any intersection point, there is no solution. That's what they are saying. We just took the same equations from the beginning of the chapter. So what I did, I just put this first equation into the first and second equation into the graph. Desmos. That's how it looks like. Hope you know already how to draw this line. When you know x and y points, substitute some x and y points, you'll get, substitute x values as 1, 2, 3, you'll get some y values. Take that x and y values so that you can graph it. Here it didn't show how the graphing is done, but hope you need to know by now. So here these two equations, when you graphed it, they are intersecting at one point, 2, 3. That is only one solution for these two equations. Now coming to the next one, infinitely many solution. They given two equation. I just kept the first equation into the Desmos, which is 2y minus 4x equals 2. I got this line. And then when I kept the second equation, which is y minus 2x equals 1 into the Desmos, I got second line, which has infinitely many solutions. Why I showed you individual graphs of individually equations, because when you draw these two lines together, actually you have to draw these two lines together. The thing what I'm showing, these two graphs, lines must be drawn together, then they looks like this. They looks like only single line. They intersect all the points. when you substitute x values as 1 2 3 4 something like that, and then you get some y values, plot that in the graph, you get first graph. Do the same thing with the second one, you get second graph. But you have to do it on the single graph only. I just did to make you understand, I did it in two graphs. You see these two graphs, these two lines are similar. They are exactly at same points. If you combine both, you'll get these kind of graph. The blue line, red line intersect at one point, intersect at all the points. This thing we say infinitely many solution. These two equations have infinitely many solutions because these two lines are intersecting at every point. Not like the previous one, they are intersecting at only one point if you put them in one graph. But if you put them in one graph, this one, they intersect at all points. The two lines coincide, which means they are intersecting at many points, so it has infinitely many solutions. Now coming to the third one, the equation 1 and equation 2. I just kept these two equation into the Desmos. I got these two lines. You can ask me how these two lines came. Same story. Just substitute random x equals to 1 2 3 4. You get y points. Both end x and y point, you graph it. You get this first line. Repeat same concept. You get second line. You can see those two lines are not meeting at all at one point. They're not intersecting at least at a point. So we say they don't have any solution. They are parallel and they do not intersect any point, so no solution. If they intersect at one point, then we say it has one solution. If they are intersecting at many points like this, when you combine these two graphs, you get these kind of graph. These two lines are intersecting, coinciding with all the points, all the intersection points. So we say these are infinitely many solution, and this one, they are not intersecting at any point. You can see both lines, they are parallel and they don't have any solution. So through graphs also, you need to identify how many number of solutions are there. Now coming to example 7, the graphs of equation y equals to 3x minus 5 and y equals to minus 2x plus 10 intersect at the point. They are intersecting at the point, which means only one point. Then what is the value of k, which means y value, x and y? This y value, if this is x and y coordinates, then they are asking us to find the value of y. It's so simple, we just have to solve it and get the value of y. The best way, two y values, you need to be a bit careful here not to get the value of x and then substitute. Here they given two y values, so just equating them is the best option to get the solution in a quicker way. Equate them because they gave both y values. So, or else you can substitute this y value in the place of this, you still get same. Then solve it, you get the value of x. So just 3x plus 2x, that's going to be 10 plus 5. Transpose this. So 5x equals 15, x equals 3. We got the value of x. We have to find the value of y. To get the value of y, what you are going to do, substitute y equals 3x minus 5. X equals 3 in this. So y equals 3 into x value as 3. So we are going to get 9 minus 5, which is y equals 4. So k value is equals 4. X comma y, that equals 3 comma 4. H comma k, that is 3 comma 4. K value equals 4. Coming to example number 8. This is also same story. You can see two equations given y values. So not to get the x value and then substitute all that story, directly substitute this y value here. The graphs of the equations in the given system of equations intersect at point. If they are intersecting at one point, what is the possible value of y? Same question. Just equate both equation. X plus 1, that equals to x square minus 5x plus 6. I'm just substituting this y value here. And then I got this equation. So just do this. That's going to be 5x. If on the left side, that's going to be 6x. And if you forward this one to other side, that's going to be x square minus 5. So what do you have now? X square. It's up to us the way, however, we deal with. I mean, we can solve in any format. That's going to be 0. Just solve this equation. You'll get it. So I'm just factorizing it. X square minus x into x minus 5 and x minus 5 and then minus 1, x minus 1, x minus 5. So x value is 1 or 5. X equals to 1 comma 5. We need to get the value of y. On substituting x equals to 1 comma 5 in equation 2, y equals x plus 1, y equals x plus 1. So here we are just substituting x equals to 1, x equals to 5, substitute. So y value equals to 1 plus 1, y equals 2. And then y equals 5 plus 1, y equals 6. So y value is 2 comma 6. 1 second. So we can write like this: when x equals to 1, y equals to 2. When x equals to 5, y equals 6. So we got 2 points. So equations are going to intersect at 2 points. I'll write a sentence. So the graphs of the two equations in at 1 comma 2 and 5 comma 6. So the possible values of y are 2 comma 6. That is possible value of y 2 comma 6. And if they didn't mention anything, don't consider that the system has only one equation. There is system has only one intersection point. That now you saw that we have two intersection points after solving it. Now coming to the next one, by watching the graph, we need to answer here how many solutions does the system have. They also give an equation, you can solve it, or by watching graph you can say how many solutions does this system. You can see the graph. This is the graph of mod x. This is the graph of y square value. Y square equals to x plus 3. This is y equals to mod x graph, and this is y square equals to x plus 3 graph. Now, how to know that how many solutions these two graphs have? Where these two individual graphs, when we combine them, when they are meeting at 2 points. So this system has exactly two solutions. You can say that way. 13.1 first problem. So you see here two equations are given. Which ordered pair is a solution? So here we can directly eliminate C and D because it's minus 8 and 8 there. Here itself they given y value is 25. So obviously the value will be 8 or negative 8. You can just substitute x value as negative 8 or something. If you keep negative 8, this value become positive and y value become more. So option B will be the answer. 8 5 is 40. So you have to take the positive value to do subtraction and get the y value as 25. Or else better I'll just show you y equals to negative 5. X value I'm taking option B 8 plus 65. That's going to be negative 40 plus 65. Y value equals to 25, which is matching with this y value. This is a shortcut. Or else you can directly substitute this y value here. You'll get the value of x and you can choose the option. Coming to question number 2. You have two equations. You have to find the value of y, solving system of equations, and you have answers here. So what is the value of y? So we already have x value clearly mentioned. So directly use substitution method to do it. I am going to substitute this x value here. So I am going to get 3 into 1 minus 3y, direct I substituted, minus 5y, that equals to negative 11. So that's going to be 3 minus 9y minus 5y, that equals negative 11. 3 minus 14y equals negative 11. Negative 4y, negative 11, negative 3, negative 14. So negative 14, negative 14 of y value equals to 1. Option C is the answer. 6x minus 5 into 20 minus 2x, that equals 12. 6x minus 100 plus 10x equals 12. 16x, that equals to 12 plus 100. X equals to 112 by 16. X equals 7. 16 ones, 16 sevens. So x is 7, then y will be x is 7. There itself answer is done because you matched with this. To confirm it, you just have to substitute your x value in this. So you are going to get y equals to 20 minus 2 into 7. Y equals to 20 minus 14, which is 6, which is option D. Question 4, they given two equations. So here it is not a good option to do the elimination. So turn the second equation to x equals to negative 15, positive 9. Then you get x value as negative 6. And substitute this negative 6 in equation. So we have equation y equals to x square plus 10x plus 23 to get the value of y. So y equals to negative 6 whole square plus 10 into negative 6 plus 23. So y equals to 36 minus 60 plus 23. So y equals to 36, 23, 46, 56,
-1, -1,
59 minus
-1.
60, y equals negative 1. To question number 5. So the graph of a system of two linear equations, these are the two linear equations, is shown. What is the solution to the system? They gave options. So what is the solution? Solution is where the equation lines, the line equations are meeting. You see the lines are meeting at this point, the intersection point. What is that? -1, -2, -1, -2, -3. So the answer is -2, -3, intersecting at -2, -3. Coming to question number 6, they given two equations. You just have to find the solution and then add up. That is the main thing here. You can see here you can take the x value as 15 minus 4y and then substitute in the first one, or else you can do it by the elimination also. Let's try doing this by elimination instead of substitution. 2x plus 5y that equals 24, x plus 4y that equals 15. So to make it similar, I'm going to multiply the equation number 2 with 2, and this is already, I'm just multiplying with this one with here, and this 2 from here. I just took I'm trying to make the x term same, multiplying with 1 and multiplying with 2. So the first equation will be same, and the second equation will be, if you multiply with 2, 2x. So on subtracting equation 2 from 1, you are going to get, this will be off, positive 2x, negative 2x, and negative y, positive 5y, negative 3y, that equals to negative 6. So negative 3 times 1, negative 3 times 2 is negative 6. So y value is 2. If you got y value, substitute that into the equations, you'll get the x value. So if you substitute this in, let's say here, if you substitute x plus 4y that equals 15, x plus 4 into 2 that equals 15, 15 minus 8, which is 7, x equals 7. So now you need to find x plus y that equals to 7 plus 2 that equals 9. Yes. So how many solutions does the given system of equations have? So for this, how many equation does it have? You can get this solution by just substituting these values into the Desmos, or you can just solve it and get it. So just solve it by elimination or substitution. Let's go with substitution. 2x minus 4y that equals 8. I'm turning this second equation as x equals to 4 minus 2y. So I'll just substitute x value here, this x value. So 2 into 4 minus 2y that equals minus 4y that equals 8. So 8 minus 16y minus 4y equals 8. So 8 minus 20y equals 8. And then minus 20y, negative 8, that's going to be 0, y equals 0. If y value is 0, x equals to 4. Substitute into this equation. So you are going to get x equals 4 minus 2y, x equals 4 minus 2 into 0, x equals 4 minus 0, x equals 4, x comma y that equals 4 comma 0. So we got only one solution, so it will be, we got only one intersection point, which means this is one solution, option B. Let's keep these values into Desmos. So the equation 2x minus 4y equals 8. 2x minus 4y equals 8. And equation 2, x plus 2y equals 4. X plus 2y equals 4. So you can see these two lines are meeting at only single point. So these two equations have one solution. If they meet at 2 points, then we say it has two solutions. Hold on for a second. So here we got two solutions after solving these two equations. Let's keep these values in the Desmos and see what happens. So the first one is y equals to x square minus 5x plus 6. y equals to x square minus 6 square minus 5x plus 6. Y equals to x plus 1. You can see here clearly the two graphs are meeting at 2 points. One is 1 comma 2 and the other one is 5 comma 6. You can solve these equations using Desmos as well. So that's what we got, 1 comma 2, 5 comma 6. So it's up to you which is comfortable for you. Or you can use that Desmos or you can solve by